Good morning, this is your Stats Sensei, Mr. Spensei, and this is a warm-up on entering data with the purpose of running a confidence interval. So our scenario, neighborhood speeding, a two-lane road with a posted speed limit of 55 miles per hour is located just outside the subdivision. Concerned that the speed of the cars on the road is excessive, the homeowners desire to estimate the mean population speed of the cars on the road. It is known that the standard deviation of the population is 8 miles per hour and that the distribution of speeds is approximately normal. During non-peak times, more than 300 cars pass by this subdivision. The residents took a random, should say took a random sample of the speeds of 12 cars. So we have a sample size of 12 in order to estimate the speed during non-peak times. The speeds of the cars are listed below. All right. So, and then it says the residents wish to construct a 92% confidence interval about the population mean. Well, the very fact that we had the standard deviation of the population tells me that I'm going to be running a z-test because it's normal. So that tells me z-test and it's telling me it's normal. They also tell me the distribution is normal, which is really important because my sample size is not large enough to say it's normal by central limit theorem, and I have data. So that's important because I needed a sample size of 30 to say it was normal by central limit theorem. I only have a sample size of 12. Also, 12 times 10 is 120, which is less than 300. So our sample size is less than 10% of the population. Okay, so what we're going to need to do is enter the data, and we'll go to stat, and we're going to press edit. And then we're just going to type all our data in, and you can see that I've already done that. So I already have 57.4, 56.1, et cetera. And I'm going to then find, it asked me to calculate the X bar. Well, the way I'm going to do that is I'm going to press the stat button, then arrow over to the word calc, one variable statistics. My data is an L1, so I don't need to do anything, but if it weren't, I'd press blue and the number one. And I find out that my X bar is 59.61666. So X bar 59.6166. All right. The next thing, it says calculate the z-scores associated with the middle 92% of the data. Well, remember z-scores, all z-scores have a mean of 0. So they're centered on 0, and they have a standard deviation equal to 1. And we're looking for this area right here, which is going to be 0.92. That doesn't look like a 0.92. I'll rewrite that 0.92 or 92%. Please remember, every time you have a percent, you can just divide it by 100. That'll give you your decimal. So here's what I need to do to find that information to get those z-scores. I'm going to have to do an inverse norm. So inverse norm. And the very first thing the calculator is going to ask me for is the area. Second var is inverse norm area, which happens to be 0.92. Then it's going to ask me the mean, and the mean of all z-scores is 0, and the standard deviation is 1. And by the way I got there is I pressed the blue button, then vars or variables, drop down to inverse norm, area, typed in 0.92, z-score of 0, standard deviation of 1, and we want the middle, so that means we need to select center because we're going to be centered on the data. Press enter a couple times, and there we have a negative 1.7506 to a positive 1.7506. So negative 1.7506 to positive 1.7506. So that's my z-scores, my upper and lower bound for my z-scores. And that's basically what we just found is this is our lower, this is our upper, and we just calculated this lower bound right here and this upper bound right here, lower and upper. All right. Appreciate you watching and look forward to seeing you on the next one. Thank you.